Hello, 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 hello. Am I audible? Am I audible? Second. Hello, 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 hello. Am I audible? Am I audible? Yeah, Mohammed Wahib. Hello, beta. So as you know that we have started a series, 20 years PYQ series for your NEET examination. So we have done couple of chapters, right? So in this particular video, we will start a work power energy, chapter number 5 from 11th physics, part first, right? So in this particular video, we are going to start Dr. N. Hello, beta. So we will be starting 50% numericals from work power energy. Okay. So let's start. If you want to ask something, if you want to ask me anything, right, you can just ask me right now. Then we will start our lecture series. Okay. Yeah. So let's start then. Okay. And one more thing, now at the end of the lecture, I will be sharing the whole PDF in my Telegram group. If you have not joined a Telegram yet, so join the Telegram group, right? I have posted my Telegram group's link in the description. You can go there and you can just join my Telegram group. Okay, so let's start today's class. 1 second. Yes, Vera. So let's start first numerical from work, energy, and power. The first numerical, like an object moving along a horizontal x direction with kinetic energy 10 joule is displaced through 3I meter, right? So as you can see here, displacement is given to me, and here you can see the force is given to me, right? Force and displacement, these two parameters are given to me. And what I need to find out, I have to find out the kinetic energy of the object at the end of displacement. So I had to find out the kinetic energy, right? So how we can do it? We all know one formula, and that is work done by all forces is equals to change in kinetic energy. We know it now. And what is work done? I guess work done is equals to force into displacement. Yes. So I can write it is force into displacement in a vector now. So work done is a scalar quantity. That's why I put a dot product between force and displacement. Change in kinetic energy means we have the kinetic energy final minus kinetic energy initial. Done. So what is force? I guess force is given to be, it is minus 2I cap plus 3J cap, then dot, and displacement is how much? It is 3I cap only. Change in kinetic energy. So kinetic energy final we have to find out, and initial is how much? Yeah, initial is given to me, it is 10 joules, right? So what I can put here? 10. So here I have 10 joules. So 2 multiplied by 3 is 6. So I can write here minus 6. Done. is equals to kinetic energy final minus 10. So therefore, kinetic energy is equals to 10 minus 6, which came out to be plus 4 joule. So plus 4 joule is my answer. Done? Plus 4 joule is my answer. That means answer C. C is my answer. The C is my answer. 4 joule. Easy, beta? Okay. So here you can get the solution of it also. So now we have question number second. Question number second is like an object falls from a height of 10 meter above the ground. After striking the ground, it loses 50% of its kinetic energy. The height up to which the object can rebound from the ground is. So that means if this is my ground, an object falls from height h. So this is my height h. Okay, height h. Object is here. Okay, it falls from ground, height h. Okay, so if the energy of your particle here is E, now it strikes ground, now goes up. Here, no, here, particular here, it loses its energy by 50%. If here my energy is E1, so here my energy would be how much? E2, and E2 is how much? E2 is equals to half of E1. So E2 is equals to half of E1. Done, beta? What is energy? No? Potential. Here, no? mgh, so I can write here that mgh2 is equals to 1 by 2 mgh1. Cancel out, gg cancel out. So I have here h2 is equals to h1 by 2. What is h1? So h1 is given to me, it is 10 meters. So I can write here what? 10 by 2. Therefore, my answer for h2 came out to be, it's 5 meter only. बेटा basically ना हम यहाँ पे discussion, we are discussing what? The PYQs, right? So PYQs means that you will get an idea na how the numerical will come in your NEET examination, right? So the hardness of the paper would be the same. Okay. अब तो ऐसा नहीं है कि यही न्यूमेरिकल आएगा. No. कंसेप्ट ऐसा ही होगा, न्यूमेरिकल ऐसा ही मैनिपुलेटेड होगा. Okay. But I am giving you a way now. If you will get some sort of numerical like this, how you need to get it, how you have to manipulate its values, and how you need to think about it, and how you can get this answer, right? So answer is 5 meter. So I guess 5 meter is option D. Yeah, option D is my correct answer. Now we have question number 3. So the potential of a long spring. So what we have? A long spring. We have a spring. Okay, spring. When stretched by 2 meter, when we are stretching the spring by 2 meters, its potential energy is U. If the spring is stretched by now 8 meters, we have to find out the potential energy stored in it. So look how we can get it. What is potential energy? Sir, potential energy initial of a spring is going to be 1 by 2 kx square, no? K x square 1 by 2, no? So I can write here, sir, initially is it U? Yes, it is U. 1 by 2 k as it is. Now what we have, x is going to be 2 square initially. Now final potential energy final is equals to, let's suppose U dash. It came out to be 1 by 2 same, and k is same. Now it is what? 8 square. Equation first and equation second. Now divide equation first by second. What I can do, right? I can just U is equals to 1 by 2 k multiplied by 2 to the 4 divided by U dash whole divided by 1 by 2 is a k 64. Look, 1 by 2, 1 by 2 cancel out, k cancel out. Done. 4 ones are 4, 4 ones are 4, it's 6. So therefore, U dash is equals to 16 times U. This is my answer. Simple, no? So this is how we will get this answer. It is 16U, that is option number C. Option number C is my answer. Easy? C, yeah. Yeah, option number C is answer. Next numerical is, and at any instant of time, displacement of particles. So displacement is given to me. It is 2t minus 1. Force is given to me. Displacement is a function of time here, and force is given to me. Now, these are all are in the SI units. So what I need to find, I have to find out power. So we have to find the power now. So now, what is the equation of power in terms of velocity and in terms of force? So we know that, sir, power is equals to force dot velocity. We know it, and force is given to be 5. But velocity we don't know. We have displacement, no? But if we differentiate the displacement with respect to time, we will get a velocity. Okay, so what I can write, I will write d by dt of displacement. Here I will write 5. So what is displacement here? Is it 2t minus I 1? Sorry, 1. Okay, it is differentiation now. So it is differentiation. So it is d by dt of 2t minus 1. So I can write here 5. The differentiation of 2t would be how much? 2 only. 1 is 0. So I guess power came out to be 5 to the 10. It is 10 only. Okay. I guess the option number A is my answer. Option number A, 10. Yeah, option number A is correct. Next question. A bullet of mass m hits a block of mass capital M elastically. The transfer of energy is the maximum. We know that in elastic collision, if we have, so maximum transfer of energy would be only if the masses are equal. So option number A is correct. We know it now. A is correct now? Yeah. Next question. A particle moves with velocity. So velocity is given to me. This is velocity. Velocity is given to me. Okay, in vector forms under the action of constant force, and force is also given to me. This is force. So we have to find out what? We have to find out power. So what is power now? Sir, power is equals to F dot V. F dot V. Okay. Force is given to me now. What is force? Force is 10 I cap plus 10 J cap plus 20 cap. Dot product with velocity is also given to me. It is 5 I cap minus 3 J cap plus 6 K cap. Now we have to apply my dot product. We have to apply what? Dot product. How we can do it? Simply I with I, J with J, K with K. 10 into 5, it would be 50. Minus 10 into 3, 30. Plus 20 into 6, 120. 120 plus 50, 170. 170 minus 30, it is 140 watt. So my power came out to be 140 watt. Okay. 140 watt. But 140 is option, which one? Option number D, 140 watt. Okay, 140 watt. Easy, no? You will get a numerical like this in the examination only. Next question is, an electric lift with a maximum load of 2000 kilogram, lift plus passenger, is moving up with velocity. That means we have something like this. We have a lift something like this. Okay, it is mass is given to be, it is 2000 kilogram, and this mass is a mass of lift, mass of passenger, is moving up with constant velocity. So this body is going up with velocity constant, and it is given to be 1.5 meter per second. Okay, no issue. The frictional force opposing the motion is 300 Newton. Okay, sir. My frictional force, now it would be how much? It is 3000 Newton. Done. The minimum power delivered by the motor to the lift in watts. So what we have to find out now? We have to find out the power delivered. We have to find out the power delivered. So how we can get it? Sir, power delivered is equal to how much? It is simply force into velocity. You know, force into velocity. 1 second. It stuck. Mm-hmm. 1 second. Okay. So force, we don't know what is the value of force. So I will take it force as it is. Now, what is velocity? Velocity is given to me. It is 1.4 meters per second. Look. So if 3000 Newton is acting downwards, there is one more force now, that is mg, that will act also downwards. Done. It is how much? 2000 kilogram. That is 2000 into g, 20,000. It is total sum is now. So what is total sum now? F net. It would be 23,000. I can write 23 into 10 to power 3 Newton. So force is how much? 23 into 10 to power 3 multiplied by 1.5. 10 cancel out. What do we have now? It is 23 multiplied by 15 multiplied by 10 to power 2. So I guess it would be 0 to 10. It will be 34, something like that. It is 34,500 watt. So this is my answer. Option number C. Yeah, option number C is my answer. Next question is 34500. No? Yeah, 34500. The energy that will be ideally radiated by a 100 kilowatt transmitter in 1 hour is in 1 hour. So what we have to find out? We have to find out energy. Energy. We know that energy is equals to power into time. Power multiplied by time. As you can see here, now every option is in joules, so it is in SI units. So I have to change the units of power, which is kilowatt, and the timing is R, into this SI units. So what is power? 100 kilowatt. Kilo means 10 to power 3. And time. What is time? 1 hour. In a 1 hour, how many seconds we have? 3600 seconds. Okay. Now look, 20, 4, 4, 3, 7. So we have 33 seconds multiplied by 10 to power 7 joule. So this is my answer. Yeah, A. A is my answer. Easy. Okay, next numerical. Next numerical is a distance covered by a body of mass 5 gram. So mass is given to me. Linear momentum is also given to me, and time is also given to me. And what I need to find out? At distance I have to find. Okay. So how to get the distance, right? How to get the distance? Okay. First of all, momentum. Momentum. Is it mass into velocity? Yes, sir. Momentum is 0.3. Mass is 5 gram. Gram, no? V is V. So I can write V is equals to 0.3 whole divided by 5 into 10 to power minus 3. It's my velocity. It's my velocity. Now, what is distance now? What is distance now? What is my distance now? So, can I write my distance is equals to, we know the speed, look, what we know that speed is equals to distance by time. I can write distance is equals to speed multiplied by time, right? Speed is how much? It is 0.3 whole divided by 5 into multiplied by 10 to power minus 3 into time. What is time? Time is 5 seconds. 5 cancel out. So it is 0.3 multiplied by 10 to power 3. Done. So 1 0 cancel out. So I have 3 into 10 to the power 2. So my answer came out to be 300 meter. 300 meter. That means option number B is correct. Option number B is correct. Okay. Now next numerical. Okay. This one is not from the WPE. It is from rotation. So we will do this one in the rotation one. Okay. Next numerical. A particle is released from height S. Okay. We have the height S. Okay. No issue. From the surface of Earth at the certain height. At a particular height, it is kinetic energy is three times it is potential energy. Okay, no issue. That means if this is my surface, this is my some sort of height S. Then from this, a particle is released from height S from the surface of Earth at a certain height. Let us suppose certain height means this height. This is my certain height. This is what? H. Let us suppose it is H. At a certain height here, right? It is kinetic energy. So here it is kinetic energy is equals to 3 times it is potential energy. Here only, right? So the height from the surface of the Earth. So we have to find out this H. And here, what is the speed of it? So these two things we have to find out. Done with that? How we can get it? As the question gives me statement, the kinetic energy is equals to 3 times the potential energy. So I can write, sir, kinetic energy is 1 by 2 mv square, 1 by 2 mv square. 3 times potential is mgh. Mg, it is h only. Why? Because here potential energy is what? Height h from the Earth surface. Okay, no issue. So what I can get now, look, m cancel out. What is v? What is v now? We know that v is equal to under root of 2gh. It is 2gh. What is h here? What is h here? I guess h is equals to the distance, no? So is it equals to s minus h? Yes, sir, it is s minus h. S minus h. So it is 1 by 2 v square under root of 2g s minus h whole square is equals to 3gh. Square and root cancel out. So we have 1 by 2 multiplied by 2 multiplied by g. Then we have s minus h is equals to 3 times g. G cancel out. 2 cancel out. So what we have now? S minus h is equals to 3 times h. So s came out to be 3h plus h. S came out to be 4 times h. Okay. Therefore, my height is equals to s by 4. So my height from this particular equation came out to be s by 4, right? That means, look, this option might be correct. This option might be correct. So now, yeah, this can be also correct, no? Yeah, so this is not correct. So now height, we got it as by 4. Now we have to find out what? We need to find out speed, right? So we know the speed is this one. We know the So where is this one? Na? Put the values now. So V is equals to under root of, it is visible, na? Yeah, under root of 2. Then G, S is S. What is H? I guess H is equals to S by 4. Yeah, it's S by 4. So here what do we have? S. It is S, 4S, 4S minus 3S, right? So V came out to be 2G minus 3S by 4 root. 2 1s are 2, 2 is 4. So my answer came out to be 3 by 2 SH root. 3 by 2 SH. So which one? Look, this one is not my answer. 3 by 2. Root is in a numerator and denominator also not. So this is my not answer. Not this one. Yeah. 3G. Yeah, this is my answer. So option number D is correct. By looking at these things, option number D is correct. Okay, this is how you can do your numerical. Okay. Next question. Water falls from a height of 60 meters at a rate of 15 kilogram per second. So water is falling from a particular height of 60 meters at a rate of 15 kilogram per second. To operate a turbine, the losses due to fractional force are 10%. That means 90% of the energy is getting converted, right, in generating the power in turbine. Only 90%. Why? Because 10% getting wasted. So how we can get it? Look better. You can see here now. It is 15 kilogram per second. It is m by t. It is what? M by t. So I can write, first of all, I can write height is given to me. It is 60 meter. So rate of dm by dt, mass falling, equals to 15 kilogram per second. These two parameters are given to me. Hello beta. NCRT. Hello beta. And in Kuraza. Thank you beta. Thank you very much. So what we have now? Yeah, dm by dt is given to be 15 kilogram per second. Now what we have to find out? We need to find out basically power generated. Okay. So basically power generated. Now I can write here power generated. It gets generated by only 90% of input. 90% multiplied by the input that we are giving to it. Why? Because 10% gets wasted in fractional loss. No, it is fractional 10% loss here, or 90%. But we have to find out the input also. No? So what is power? What is power? Power came out to be, sir, mgh only. mgh. But my mass is not constant. It is varying now. So I can write gh, then dm by dt. I can write like this. Okay, energy by time. Now you can also write this energy by time here. Differentiation of it. Okay, what is G? It is 10. Height is given to be 60. dm by dt is 15. So 15, 6. 6 is 1000, right? So yeah, 0, 0, it is 600 multiplied by 15. Okay, it will be 30. Yeah, it will be 9000 watt. 9000 watt. So my power came out to be 90%. But this 90%, now only the 90% of this 90%, only the 90% of the 9000 watt gets converted to the power generation. So what I can write here? I can write here 90%. It is 90 by 100 multiplied by 9000. 9000. 20, 20 cancel out. It is what? 90 into 90. Okay. 90. We have 9009. Yeah. 20 cancel out. 90 into 90. 0, 0. It is 81. So I can write 81 into 10 to power 2. Or I can write 8.1 10 to power 3. And 10.3 is kilo. So I can write it is 8.1 kilowatt. It is what? 8.1 kilowatt. So I guess 8.1 option B. Option B is correct. Option B is correct. Now next numerical. Okay, so by body of mass 4m, so we have a body. We have what? We have a body. This is my A body and it is having a mass 4m. It moves with speed u, collides with another body B of 2m, and its velocity is given to be, that is so u dash, it is equals to be 0. The collision is head on. Okay, the collision, which type is it? Is head on collision and elastic, u equals to 1. Now, in nature, after the collision, the fractional energy lost. So what is the formula of fractional energy loss? It is change in kinetic energy divided by kinetic energy is equals to, it is 4 times mass multiplication of both them divided by m1 plus m2 whole square. 4 m1 is given to be, it is 4m, m2 is 2m multiplied by 4m plus 2m whole square. Clear? 4 4 16, 32. It is 32m square. 4 2 6, 6 36. It is 36 m square. M square cancel. It is 32 by 36. I guess it is 8 by 9. 8 by 9. So my answer is what? 8 by 9. What is 8 by 9? Option C is correct. 8 by 9. Done. Next numerical, we have a force. Force is equals to 20 plus 10y. That means force is a variable one. Okay, it depends on the y. In y direction, where F is in Newton and y in meters, work done by this force to move the particle from. Look, so whenever we have to find out work done, and force is given in some variable forms, in dependent form, so we have to use the integration part. So what we can do here, I will use the integration part. No? So by integration, we can find it as answer. Look now here. Okay, once again. So work done is equals to integration of force multiplied by the distance that is given to me, and it is equals to, that is ds, right? Limits are 0 and 1. So what is f? So f is 20 plus 10y. Then what we have? ds. It is given to be, no, I have to do with respect to ds now. But here I don't have ds now, I have dy. Okay, so with respect to dy, integrate from 0 to 1. Integration of 20 would be 20y. Integration of 10 would be 10y square by 2. These limits are given to me. These are 1 and 0. 2 ones are 2, 2 5s are 10. Now what I can write now, the work done came out to be, it is 20, upper limit is 1 only, multiply by 1 plus 5 into 1 square minus lower is 20 into 0 minus 5 0 square. 20 into 1 is 20 plus 5. Clear? So my work done came out to be, it is 25 joule only. This is what? 25 joule only. 25 joule only. Option number D is correct. Okay. Next numerical. 25 joule. A mass M is attached to a thin wire and welded in a vertical circle. The wire is most likely to break when inclined at an angle of 60 degrees from vertical. The mass is at the highest point. The wire is horizontal. The mass is at the lowest point. We know it will break at the point while tension is maximum. So tension is maximum only at where? The lowest point. So answer D is correct. tension. If we are look, if we are having any vertical circular motion thing, we know that every time the tension will be maximum at the lower and it is minimum at what, at the upper portion. Yeah. Next question is, a particle of mass 5m at rest suddenly breaks on its own into three fragments. So basically, it gives us the idea that it suddenly breaks off its own. That means we don't have any external force. If there is no external force, so we can use the conservation of momentum, right? One kind of clue from first sentence. Then two fragments of mass m each move along mutually perpendicular. In three parts, two moves perpendicular to each other, I and j. That is about I and j with v speed, and speed is same, right? The energy released. So energy released means the summation of kinetic energy of all of the three that we are having. No? Look, if the whole mass of the particle is what, 5m, it breaks into three fragments. The masses of two fragments m and m. That means the mass of the third one should be what, 3m. Okay. So what I can write here now, look. It breaks into three fragments. One fragment with mass m, second with m, and third with 3m. If this one goes with velocity in I cap, this would be in j cap, and we don't know this particular velocity, right, of this one. So what I can write, there is no sort of external force, so I can write P is conserved. P is conserved, momentum is conserved. That means summation of the moment of all these three is 0. Okay, yes. So mass is 3m. 3m. It is velocity. We don't know it is velocity. I can write it is v vector. Plus second one, it is mass is m. Velocity v. That is, it is in I cap. Plus third one, mass is v. Velocity is v. It will be in j cap. Is 0. Is 0. Now look, I can take m in common and I can cut it out. So I will get here 3v vector plus vi vector plus vj vector. So v cap equals to 0. I can write 3v vector is equals to minus vi cap minus vj cap. I guess v came out to be minus v by 3 I cap minus v by 3 j cap. Okay, this is my what, velocity. But I don't need to get velocity now. I had to find out the energy. So look, for energy, what I can do from here now, look. So I can write energy release here. My energy release. So my energy release will be equals to 1 by 2 mass m velocity square. First of all, first one, this one, no? Plus same 1 by 2 m v square for this one. Plus 1 by 2 m. M is equals to 3m. V square, what is v? This v, no? But it is in vector form, so I have to find its magnitude. It would be equals to minus v by 3 whole square plus one more time v by 3 whole square, then root. Okay, so I guess its answer came out to be v by 3 under root 2 only. So now here I had to put it as value only, right? So 1 by 3 m v square. So now just it came out to be 1 by 2 it is only mv square plus 3 by 2 m v square 9 into 2. 2 cancel out. So I can take mv square common. 3 1 this is a 9 also. So I have 1 plus 1 by 3 only, no? 1 by 3. It will be here. It would be how much? 4. It is 4 by 3 mv square. So my answer came out to be 4 by 3 mv square. That means option number 4 by 3. Option number D is correct. Option number D is correct. Yeah, D is correct. Next numerical. A moving block having mass m. Okay, we have moving block mass m collides with another stationary block. Okay, we have a moving block. We have moving block m collides with, it is moving now, velocity also v. It moves with the another stationary block, that its velocity is 0. It is 4m. So basically this is lighter one only, lighter, this is heavier, no? So lighter block comes to rest after collision. That means here, so I can write this u1. So u1 is u, u2 is 0. Now after collision, m, it is velocity, v1 is equal to 0. The more v1, it would be, which one? 4m. It is velocity, v2 becomes v. Then the value of coefficient of restitution e. So we have to find out e, right? So what is e basically? It is velocity v2 minus v1 whole divided by u1 minus u2. Look beta, I think v2 is v minus v1 is 0 divided by u1 is u, u, no? Okay, u, and u2 is 0. Okay, it came out to be v by u. V by u. Now, look here, I will write the initial momentum will be equal to final momentum. Okay, initial momentum is always now in any case, if you are doing with the elastic, or if you are doing with inelastic or perfectly inelastic case, in all these three, now the momentum is conserved always. Okay, so initial momentum is always equals to the final momentum. What is the initial momentum? Mass of initially u initial, mass of initial second one u initial second one, then m1 v1 plus m2 v2. Look, u2 is 0, 0, v1 is 0, v1 is 0. M1 is m, u1 is u only, is equals to m2 is 4m, v2 is v. Cancel out, so v came out to be u by 4. V came out to be here u by 4. Now put this value here. So therefore E came out to be, E is equals to V. What is V? V is u by 4 whole divided by what we have u, right? U cancel out. So my answer came out to be 1 by 4. 1 by 4 will be equals to 0.25 only. 0.25 only. So the answer is B, 0.25 only. Now next one. Okay. A body initially rests along a frictionless track from height h. Just complete is a vertical circle. So if a body in a circular motion needs to complete a vertical circle, na, just completes. So do you know what should be the velocity at the end point? What should be the velocity at the end point? Okay, it should be minimum under root of 5 r. R is the radius. R is the radius. So here, if this particle needs to complete the circle, so it is velocity at the lower point should be equals to minimum at 5 gr. And where from the particle will get this velocity? It will get its velocity from the potential energy. So look now, this particle will lose its potential energy. This particle, it is mgh. So it is here at this particular point, it is potential energy is how much? mgh. So this mgh will get converted into this particular thing, right? So can I write here loss in potential energy? Loss in potential energy is equals to gain in kinetic energy. I can write it now. Gain in kinetic energy. So potential energy loss. So I can write it is only mgh. Gain in kinetic would be 1 by 2 mv square. 1 by 2 m. What is v? V is equals to under root of 5 gr. What is r? I guess radius is equals to diameter by 2. Now I can write d by 2 here, because d by 2 is given to me now. D by 2 square. Cancel out. Cancel out. So GH is equals to 1 by 2 5 GD by 2. GG cancel out. So I think I had to find out H now. So H is equals to 5 by 4D. 5 by 4D is my answer. 5 by 4D, I guess option number D. Yeah, option number D is correct. 5 by 4D, and easy one also, right? Okay. So consider a drop of rainwater. So what we have a rainwater of mass 1 gram. That means 1 into 10 to the power minus 3 kilogram. Falling from a height. Height is also given to me 1 kilometer. Okay, 1 kilometer is 1 into 10 to the power 3 meters. It hits the ground with speed 50 meters per second. Take the constant with a value of 10 meters per second square. The work done by the gravitational force and the resistive force of air is. So what we have to find out? Work done by the gravitational force and work done by the resistive force. Okay. So how we can get it? Look now. First of all, mass is given to be 1 gram. That is 1 into 10 to the power minus 3 kilogram. Okay, height is 1 kilometer. That is 1 10 to the power 3 meter. Velocity of strike, now it is equals to 50 meters per second. G is equals to 10 meter per second square. Okay, so what I need to find? Work done by gravitational force. So gravitational force means work done by gravity. So I can write it is work done would be force into displacement. What is force? I guess it is mg, na? And height is h, displacement. So m is 1 into 10 to the power minus 3. G is 10 to the power 1. And height is how much? 1 into 10 to the power 3. Look, cancel out. So we have 10 only. So work done came out to be 10 joule only. For gravity, it is how much? 10 joule only. Now we don't know any formula now by which we can find out the resistive force directly. So how we can get it? We can use the work energy theorem. Work done by all the forces is equal to change in the kinetic energy. So I can write work done by gravitational force plus work done by resistive force is equal to change in the kinetic energy. I can write like this, no? Work done by gravitational force is 10 joule, which is given to me, and work done by resistive force, it is not given to me. We have to find out, and the change in the kinetic energy would be 1 by 2 mv square. So 1 by 2 m. What is m? M is 1 into 10 to the power minus 3 mv. What is v? It is 50. So I can write 50 multiplied by the 50. Look, 1 0 1 0 cancel out. So I can 2 0 cancel out now. So I can here only 1 now. Okay, 2 0 cancel out now. So I can write look, WR is equals to 25 into 10 to the power minus 1 divided by 2 minus 10. Is this how much? 12.5. So 12.5 10 to the power minus 1 minus 10. Okay. So it will be 1.25. 1.25 minus 10. So I guess my answer is minus 8.75. Minus 8.75 and 2. I think option C. Option C is correct. Option C is correct. Okay. Now next one. Okay. The particle of mass 10 gram moves along a circle of radius 6.4 centimeter. Okay. With a constant tangential acceleration. There is no issue. What is the magnitude of this acceleration if the kinetic energy of the particle becomes equal to the 8 in 10 to the power minus 4 joule by the end of second revolution? That means n is equals to 2, no? Second is n equals to 2. Okay. How we can get it? Look, mass is given to me 10 grams, 10 to 10 to the power minus 3 kilogram. We are just transferring them into what? SI system. Radius is given to me how much? 6.4 centimeter, that is 10 to the power minus 2 meter, with a constant tangential acceleration. Okay, no issue. What is the magnitude of this acceleration if kinetic energy is this much? If my kinetic energy is given to me how much? 8 into 10 to the power minus 4 joule. Okay, so basically, how we can get it? Simple, by using work energy theorem. So I can write work done by all forces is equal to change in kinetic energy. So how many forces we are having here? Sir, one is by tangential, the second would be the centripetal. No? So I can write work done by tangential plus work done by the centripetal is equal to change in the kinetic energy. So it will be kinetic energy final minus initial. Initial is always 0 here in the case. So work done by tangential. So it would be force into displacement. So I can write force tangential into displacement. Work done by centripetal will be always 0. Why? Because theta is here how much? 90. It is how much? 0 then. And kinetic energy final is going to be how much? 8 into 10 to the power minus 4 joule. Okay, beta. But what we have to find out? Okay, acceleration. So what is force now? What is force now? Force is equal to m into a, that is mass into acceleration. Displacement is equal to 2 pi r, but it is second round, so 2 into 2 pi r. 8 into 10 to the power minus 4. Okay. Now, so AT is equal to 8 10 to the power minus 4 whole divided by mass. Mass is 10 into 10 to the power minus 3 into 2 to the 4. It will be 4 into pi into r. What is r? R is equal to 6.4 into 10 to the power minus 2. 4 ones are 4, 4 twos are 8. Okay. 2 ones are 2, 2, 5. Okay. 2 ones are 2, 2 twos, 2 3 are 6, 2 twos are 4. Done. It is, look, 1, 2, then 2, 2, 4, 4, 4 cancel out. What we have now? We have here nothing upside. So we have here now pi multiplied by 3.2. 3.2. Okay, so I can have 1 divided by 3.14 into 3.2. So it would be 929. So it would be how much? 9 by 24. Yes, like if we have that utility 9 by 900. 1 by 900, I guess 0.1 something, no? Yeah, 0.1 something. So it is 0.1 something. Yeah, answer is C. C. C is my answer. Next one. A body of mass 1 kilogram. What is timing now? Okay. So what do we have now? We have now, 1 second. Okay. Next numerical is a body of mass 1 kilogram begins to move under the action of time dependent force. So time dependent force is there along the unit vectors x and y. So we have to find out the force, sorry, the power. So what is power in the particular case? How we can get the power basically, right? So as we all know that the power is equal to force into velocity. So I can write simply, sir, power is equal to force into velocity. Force is equal to 2 ti cap plus 3t square j cap. And what is velocity is given to me? Mass is given to me now. Mass is given to me. What is mass now? Mass, yeah. Mass is 1 kilogram. Mass is 1 kilogram. Okay. Okay, so only mass is given to me, and by this particular thing, what I had to find out, velocity. So basically, we know that we can do one thing now, that look, if we have force and if I divide the force by mass m, what I will get acceleration. Okay, force is 2t I plus 3t square j cap. Whole divided mass is 1. So acceleration is same as it is. Now we got acceleration also, but I need what? Velocity. So is there any relation which relates acceleration and velocity? Yes. So if I do the integration of velocity, the integration of acceleration, I will get the velocity. So velocity will be equal to integration of acceleration with respect to time. Okay. So I can write it is 2t only plus 3t square. I will do this what? Integration. For 2t, it will be 2t square by 2. For 3, it will be 3t cube by 3. 3 cancel out, 2 cancel out. So my velocity came out to be t square I cap plus t cube j cap. I put the values here now. T square I cap plus t cube j cap. So 2t, no? 2t into t square. So is it 2t cube? Yes. Plus 3t. So it is 3t power 5. This would be my answer. 2t cube, 3t4. No, it is not. Yeah, B. Option number B is correct. Option number B. Next numerical. Okay. What is the minimum velocity with which a body of mass m must enter the vertical loop of radius r so that can complete the loop? Under root 5 here, we know now. We know it. It is this one B. We know it. Okay. The bullet of mass 10 gram. Okay. Moves horizontally. So if we have here bullet, so we make what? A bullet. So it is mass is equals to how much? 10 gram. This is 10 into 10 to the power minus 3 kilogram. And it is speed. That is mass of bullet. Velocity of bullet. Speed of bullet is how much? It is 400 meters per second. Okay. Citrac is a wooden block. So here what I have? Wooden block. And it is mass of wooden block is given to be, it is 2 kilogram. Okay, and its velocity initially would be equal to how much? 0. We know it. Which is suspended by a light thread. Okay, its length is 5 meter. This is my initial condition of it. Okay, as a result of the center of gravity, okay, center of gravity of this one found to rise a vertical distance 10 centimeters. So after some time now it will be here now. When the bullet will enter it now, so it will be like this. So this displacement is given to be how much? 10 centimeters. That's 10 into 10 to the power minus 2 meter. Okay. The speed of the bullet after it emerges. So here it is v dash. So I had to find this v dash. So how I can get it? Basically, now we know this. There is no external force, so I can use a conservation of momentum. I can write initial momentum is equals to the final momentum. Initially, mass of bullet is given to be how much? I can write mass of bullet, velocity of bullet plus mass of wooden block, velocity of wooden block is equals to mass of wooden block, velocity of wooden block plus it is v dash. Let's say it's v dash. And then mass of bullet, velocity of bullet. Wooden block's velocity initially is 0. I can put here 0 only. There is no issue. So look, mass of bullet is how much? 10 into 10 to the power minus 3. Okay. Velocity is 400. Done. Wooden mass is 2 kilogram, and velocity of wooden block, I don't know it. I don't know basically. Because initially it was rest, but later on I don't know. Plus, mass of bullet is how much? 10 into 10 to the power minus 3 kilogram. And velocity of bullet, I don't know this one also. So I have to find out what? Velocity of bullet. But here now, I have two variables. So I need to get rid of the one variable. So how I can do it? Look, if this is my initial condition, when the bullet is inside now, at this particular point, if this is my initial condition, this is my final condition. So between these two conditions, I can use the conservation of mechanical energy here. I can use it. Yes. So look, kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. So what is kinetic energy initial? Initially, can I write like this, sir? It is 1 by 2 mv square. Yes, 1 by 2 m v. Can I do v? No, yeah, v. Okay, v1 square equals to kinetic energy final is 0. Look, initially potential is 0, finally kinetic is 0. What is potential now? It will be mgh. So I can write mgh. Look, m cancel out. So how to get velocity? So velocity is equal to under root of 2gh. Okay, 2 is 2, g is 10. What is height? Height is 10 into 10 to the power minus 2 root. Minus 2, just cancel out. So my velocity came out to be, velocity of block basically, it comes out to be under root 2 only. So here, what I can write here now, look, 1023. So this 102030 cancel out. So I have 4 here. 4 is equals to 2. It is under root of 2 also, plus 10 to the power minus 2 VB. Okay, so 10 to the power minus 2 VB came out to be, it is 4 minus 2 under root of 2. Then VB is equals to 4 minus 2 under root of 2 whole divided by 10 to the power minus 2. So it is 4 minus 2 into 1.7, 14, 3.4. It is 117. Yeah, it will be 117 point something. That's a 1 meter per second. It will be like this only. Okay. So is there any option? 117. Look, see. Yeah. So the near one is 120. So I can just put it out 120. Now next numerical we have two identical balls A and B having velocities 0.5 meter per second and 0.3 meter per second respectively, collides elastically in 1D. Elastically, no? Okay. The velocity of B and A after the collision respectively will be. So look, if we have the identical balls case, A, B, their velocity is 0.5 and 0.3. Okay. And if they are colliding elastically in a 1D, their velocity will get what? Interchange. Okay. So here what we have 0.5 meter per second. It is basically 0.3 meter per second. So it is initial now. So finally it becomes, I guess, minus 0.3 meter per second, and it is 0.5 meter per second. Which one? Option number B. Yeah, option number B. No, how option number B? So yeah, velocity of B now. The velocity of B, then A. So it is, yeah, option number B is correct. Next one, question number 25. A particle moves from point. So we have initial point, we have final point. So we can find displacement. When a force is also given to me now. So work, what is work? Force into displacement. Work done is equals to force into displacement. Force is how much? It is 4I cap plus 3J cap. Displacement, it is final. What is final? It is 4J cap plus 3K cap minus 2I cap plus 5J cap. I can use it is 4I cap plus 3J cap. Then it is 4J cap plus 3K cap plus 2I cap minus 5J cap. So I can write 4I cap plus 3J cap. Then I have 4J minus 5, it is minus J cap. I can write here now in every order thing. I will write 2I cap minus J cap plus 3K cap. Now 4 to the 8. It is 8. 1 into 3 minus 1 minus 3 and it is 0. I guess 5. Yeah, 5 joule is only answer. 5 joule. Option number C is correct. Done. So I guess we are done with 25 numericals. Yeah, rest numericals we will discuss in the next class. Okay. Okay, then I guess you don't have any confusion now. So let's complete or let us end today's class. Thank you, Ada. Thank you very much. Bye.